Mathematics problems, you'll encounter things called 2 or 3 force members. A 2 force member is something that's shown here, where there are only 2 forces acting on it. So the red dots here are pin joints. And what you can know, since it's a statics problem and it's only 2 forces on it, is that the forces will be along this line of action, joining the 2 joints, and the forces will be equal or opposite either. So they'll be either inboard, as shown like so, or they'll be directed outboard. And you know this because it is a statics problem. So if they weren't along this line of action, if force A was something like this, and force B was something like this, then it would be rotating along some axis, because these are the only forces acting on it. Same thing if they were along the same line of action, but the force A was real big here, and force B was small, it wouldn't be a statics problem, it would be a dynamics problem, because this force would be pushing the member up. So when you see something where only 2 forces are acting on it, you know the direction of the forces, and you know that they'll be canceling each other out, either directed inboard or directed outboard. Another kind of situation which is helpful to recognize is a 3-horse diagram. This is cinder blocks supporting a plank, supporting a rope, supporting a bucket, which goes down a well. You're going to have a force directed downward, that's the tension in the rope, and these cinder blocks are going to have a reactive force directed up and inboard, just like this. What you know from these is that the line of action on these forces will intersect at some point, that is, they'll be concurrent at some point. So here the line of actions would intersect somewhere up above the screen, and you can just kind of extend these force vectors up. You can think of it like a teepee. If you have only 3 forces acting on it, they'll make a teepee, and they'll all be concurrent at this point, the apex of the teepee. In some situations they'll intersect at infinity, but if not, it can be helpful to find where to help find angles. So this is an example given in the textbook of a 3 force member diagram. You have joints at the red locations, the red dots, and then you have a 400 Newton force on this lever, and you want to find the force here, the reactive force on this joint. So originally this looks like a 4 force member because you have joint, 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 and then force. So reactive force, reactive force, reactive force, and induced force. But you can quickly see right here that this is in fact a 2 force member right here. And so you're able to just draw a line. That's the line of action of this force. And you're going to know that this line of action will intersect this line of action, the 400 Newton force, right here, and that'll be the apex of your teepee. So first thing you want to realize is that this line of action of this force, this reactive force, will also be concurrent at this point. We'll call this point O. We know from the measurements here, 0.2 up, 0.2 over, right here, this is a 45-degree angle. Theta equals 45. And we know that since this goes 0.5 up, and it's a 45-degree angle, it'll also go 0.5 over. 0.5 over. So we know that they adjoin at 0.5 over is where the apex of this teepee is. So now what we need to do to get our system of equations is to find this angle here. How to find it? We have all our measurements pretty much already set up for us, so all we need to do is take an arctangent and of the opposite side of this imaginary triangle here. So the opposite side is going to be 0.2 up plus 0.5 up, 0.7, That's the length of this side of the triangle. And then we need to find this length. Well, we know from this point to here it's 0.5 over, but we're starting here at 0.1, so it's 0.5 minus 0.1, 0.4 over. This is tangent to the minus 1. So theta here is going to equal 60.3 degrees. And that's all the information we need to go ahead and start solving the problem. We can write our sum of the forces equation, sum of the forces in the x direction. We've got 400 newtons, and that's this force. We've got plus sine of 45 times F1. We're going to label this F1. This is the reactive force. It's going to be directed towards the apex of the TP, and we'll label this F2. So F1 has an angle of 45 degrees. F2 has an angle of 60.3 degrees. So F1 and F2. Plus, and my apologies, this should be cosine of 45 because it's directed in the x direction. Cosine of 45 times F1 plus cosine of 60.3 times F2. Since it's a statics problem, it equals 0. Now we go sigma of the forces in the y direction. This has no y component since it's horizontal. And to relabel these real quick, we're going to have the sine of F1 and then the sine of F2. So we have sine of 45 times F1 plus sine of 60.3 times F2, and that should equal 0. We're able to take these equations, put it into a matrices, and just solve for the matrices. If you do so on your calculator, you're going to get force 1 is going to equal minus 1,317 newtons. And F2 is going to be equal to a positive 1,072 newtons. The negative pretty much means that F1 is directed inboard, or directed down and to the left, and F2, since it's positive, it's directed up. And that's pretty much how you solve a statics problem using a 2 and 3 force members. And these can be helpful in solving a lot of statics problems, so it's good to recognize them. Thanks for watching.